Good evening, everybody. Welcome to Chem 1211 with your host, me, Dr. White. How you doing, everybody? Tonight, I'll be doing a review for Quiz 1. But before I do the review for Quiz 1, there's something very important I need to talk about. And that is about two-thirds into last semester, the chairperson of the chemistry department issued some rules, and they concern tests and quizzes. And being employed by the chemistry department, I have to follow those rules. The first rule is I can't give extra credit on quizzes and tests. I used to, but I can't now. She uh, said no. The other thing I did, and I had been doing for a number of years, and I'm not the only faculty, to cut down on memorization, I would put in the back of quizzes and tests, my tests. Quiz 1, I don't have one, but the other ones I would, excuse me, called important information. And I'd give you things that you would have to know how to use, but you didn't have to know how to memorize. She put out a rule, we can't do that anymore. So when you look into videos and I say, well, you don't have to memorize this because it's an important information at the end of a quiz or a test, unfortunately, that's no longer true. Now, I will have the important information. It's already in the lecture section of Blackboard, but those are things that you have to memorize. And the best way to memorize something is to write it down 5 times, and each time you say it, and that gets it burned. Before I started putting important information, I would teach my 1211 students to do that, and it worked. But like I said, I have to follow the rules, but I added a couple extra credit projects to make up for the bonus points I couldn't put on tests. Don't tell anybody. Keep it a secret. Watch out, Dr. White's sneaky. All right, let's get going. If we go to Blackboard, and I posted this on February 5th, and an email went out this Thursday the 13th. Luckily, it's not Friday the 13th. Well, actually, those are lucky days for me. But anyways, at 8 a.m. or earlier, I will be emailing you the password for Quiz 1 PDF file, which is not yet available, but will be available Thursday morning in the assignment area of Blackboard. You will download that quiz and use the password to open it up. Now, you'll have until Friday, the 14th. By the way, happy Valentine's Day to everybody. You can send Valentine's to Dr. White. My students have. Anyways, happy Valentine's. And till 8 p.m. to take quiz 1 and upload your answers as a single PDF file. I have in the assignment area, just like in the labs, how to make a single PDF file. You can use a scanner. I don't know if you can see my printer scanner, or you can use the app with a cell phone cam scammer. Don't spend any money, use the free version. Now, listen carefully. If you do not have a printer or access to a printer, you can just take a blank piece of paper, write your name at the top, and then write the question number and your answer. Again, if you do not have access to a printer, you can take a blank piece of paper, put your name on top. You might want to put quiz 1 and put each problem number and your answer. You do not have to copy the question. Now, I reserve the right to subtract up to 25 points for anyone who does not follow instructions or does not upload your quiz 1 answers on time. Quiz 1 has 3 pages, 9 problems. 2 of them are multiple choice. It's worth 50 points. It covers chapters 1 and 2. I'll be going over this stuff, along with the number of protons and electrons from the periodic table. I'll cover that tonight too, along with the names and chemical symbols of the key 30, I think it was 37 key elements I asked you to learn. To do well on quiz one, watch my videos for those chapters, which is in the syllabus, and do the problem sets for those chapters. And if you can do the problems in the problem set correctly, you'll be in good shape. Now, I'll have a Zoom meeting tonight. Now, a couple of things. One, I don't know if you caught it in one of the videos. I teach by my golden rule of teaching. What's that? And that is, I don't do it to my students what I didn't like done to me. Therefore, listen carefully. My tests are doable. Take all the time you want as long as you can get it uploaded. And normally, if we were face to face, I'd give students 40 minutes, and really it'd only take you 25, 30 minutes to do the quiz. And I don't write a test or quiz where only the smartest person in the room can finish. That's not right. The other thing I do, every question on my quizzes and my tests, I'll have covered the concept behind that question, how to do it, at least twice, usually more, in the videos. And so that will be quiz number one. Now, word to the warning, do not cheat. Don't go to the internet, don't get help from other people. I put things in my quizzes and tests that I catch people cheating. Unfortunately, I have. Dr. White can be very clever at times, and I have been. So if you do the practice problems and watch the videos, you'll do well. All right, let's get going. Now, originally, I used to, before we had to give tests at the COD testing center, and that's when I started giving quizzes. Tests, I would give 4 tests during the semester, and the department changed the rules on that. So quiz 1 and 2 would be like my test 1 in the past, and I was lazy and I haven't separated the review. This file is in the lecture section of Blackboard, cleverly named Chem 1211 Quizzes 1 and 2 Review. So you can find us. All right, let's get started. In chapter 1, I talked about the 4 branches of chemistry, and you should know at least one of them. Organic is the best. Dr. White's an organic chemist. Then inorganic, physical, and analytical. Now, I asked you to learn these chemical symbols and their names, and let me open up something. Hold on one second. I got to sign in. All right, sorry about that. Let me just check. You all see. This is the periodic table you should use for quiz 1, all the other quizzes in my test. You'll be able to download this from the test area. It's also in the lecture folder if you want a head start. And notice, oh no, it doesn't have the names of the elements. Well, you've got to learn the key ones. Dr. White's nice. I'm not making you learn all of them because some of these I will never ever deal with. Like 103 LR, I just happen to know for chance is Lawrencia. I have never and will never use that or encounter it, so I learn it. But carbon, you should know, C, N is nitrogen, H is hydrogen. Li is lithium, Na sodium, K potassium. And the list I just showed you, you should be able on a quiz, if I ask what's the symbol for oxygen, you should know it's O. And if I ask what's the chemical symbol for chlorine, you should know it's Cl. Or one of my favorite, argon. I used a lot of that in graduate school, Ar. And by the way, you should know krypton is Kr, but in our universe, krypton is a colorless gas. It's not a green solid that kills Superman. And you should know these. And for these are the only ones you need to know the name and symbol. All right, next I started in chapter 2, the metric system. And the metric system has key prefixes that you should know. Only a couple, there are a lot more. They're in our daily life. KILO, kilo or kilo, is 10 to the third. That's 1,000. Milli is 10 to the minus third or 1,000. And centi is 10 to the minus 2 or 100. And if you've ever watched any movies about drug smuggling, they'll say, oh, we're bringing so many keys at midnight on the boat. I forgot what movie that was from, like a lot of them. And that's shorthand for kilogram, and that's 1,000 grams, 10 to the third times grams. If you work in the medical industry, or not industry, in a doctor's office or anywhere that uses a syringe, the syringe sometimes will be marked in milliliters. A milliliter is 10 to the minus third liter, or 1,000th of a liter. And you should know that. All right, next I talked about scientific notation. How to convert, you should know how to convert a number to scientific notation. And the rules are the decimal point and the decimal number is moved to the position behind, meaning to the right of the first number, non-zero number. And the exponent for the exponential term, I'm going to show you some examples in a little while, is equal to the number of places the decimal point is moved. The exponent is positive if the number is greater than 10. The exponent is negative number if it's less than 1. Now, I've never put on a test, and I rarely encounter it in my life, that the exponent is 0 when the number is between 1 and 10. You'll never see that on my test. Oops, I gave something away. All right, let's take a look at how to do this. I was charging up my stylus, so it helps to have it to write on my tablet. If you were asked, write the following in scientific notation, okay, how would you write 3,100? Well, if there were a decimal point right here, how many times do you have to move it to the right of the first non-zero number? 1, 2, 3. Now, if there's no decimal at the end, which there wasn't, you drop the zeros. Now I moved it 1, 2, 3. 3,100 is greater than 10, so it's 10. And the number that goes up here, the exponential, we moved it 3 times, it's a positive number. would be 10 to the third. All right, let's do this one. Write this in scientific notation. Well, look, there is a decimal point. So now we have to move that to the right. I hope you all know left from right. I hope you do. Anyways, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Lead zeros are dropped. Now a 0 after the decimal point is not dropped. And this number is less than 1, so we moved it 5 times, but because it's less than 1, this is a negative number, and that would be 5.10 times 10 to the minus 5. You know something? I'm going to share the fun. I've been hogging all the fun. Here's one for you to try. Why don't you write this in scientific notation? Your turn. I'm going to try and give everybody time to finish. And give me a thumbs up when you're done. You either use the emoji, or if your screen's on, you can do that. All right, looks like everybody's done. Well, if there were a decimal, it would be here. There's not one. So we move it to the right of the first non-zero number. 1, 2, 3, 4, 5, 6, 7. We moved it 7 times. By the way, this is how I write the number 7. It's the European or German way. I just think it's cool. So zeros at the end, you drop. So it'd be 7.961. Now this number is much greater than 1. So it's 10, and this number here will be positive. And let me get rid of the arrow out of the way. And that's how you do it. All right, next, when we deal with numbers, numbers mean something, and we call that significant figures. That tells you how accurate a measurement is. And you should know how to determine how many significant figures are in a number. Now, there are rules. And the first rule is all non-zero numbers are significant. Next, zeros may or may not be significant. Well, that's not helpful. Wait, lead zeros at the beginning of a number are never significant. Confined zeros, zeros between non-zero numbers, are significant. Trailing zeros, that's zeros at the end of a number, are significant if a decimal point is present. That should be decimal point. Trailing zeros, those at the end of a number, are not significant if the number lacks an explicitly shown decimal point. So these are the rules, and hopefully you've been practicing them. Let's go through 1 or 2 examples. If I were to ask on a quiz, How many significant figures are in that number? Well, all non-zero numbers are significant. 1, 2, 3, 4. So there's 4, and I'm going to abbreviate 4 significant figures. Now, if I look at this number, how many significant figures? All non-zero numbers are significant. Zeros at the end with no decimal are not. So this is 2, and I'm going to really abbreviate now, 2 significant figures. Now, if we look at this number, guess what? We have a decimal point. Now, zeros that the lead zeros are not significant. So these are not significant, but non-zero numbers are significant, and this would have 3 significant figures. Let's do this one. How many significant figures are there? Well, all non-zero numbers are significant. Here's 3 of them. Notice this 0 is surrounded by 2 non-zero numbers, so that 0 would be significant now. Now, we have a decimal, and zeros at the end of a number with a decimal are significant. So this would be 1, 2, 3, 4, 5. This would be 5 significant figures. And you should know how to do that. There are practice problems, and it's in the videos. All right, now, there are times when you do mathematical operations like multiply, divide, subtract, or add, you have to round off numbers. And if the first digit to be deleted is 4 or less, simply drop it and all the following digits. If the first digit to be deleted is 5 or greater, then that digit and all that follow are dropped, and the last remaining digit is increased by 1. Now, since you're going to be using a calculator in scientific notation, what I'm going to ask you to know how to do gets a little easier. And the question is, how would you round this off to 2 significant figures? Well, you keep the first non-zero number, keep the next one. That's my 2 significant figures. And then the 7, that's what I'm going to use to round off. And throughout my videos, I use this double squiggly line. I don't know how I came up with it, but that's what I use. You don't have to, but, and this number, is it 4 or less or 5 or greater? And time's up, it's 5 or greater. So I'll drop that and increase this by 1. This part you never change. And that would be 2 significant figures. And the question would be, round this off to well, let's make it 3 significant figures. So how do we do that? We keep the 1, first non-zero number, next one, significant figure, next one. Those are my 3 significant figures. And the next number I use to round off. Is that 4 or less or 5 or higher? And how do you like my sound effects? Don't answer that. It's 4 or less. So I will drop this and everything else. This never changes. And the answer would be 1.61 times 10 to the 8th. Now, why do you need to round off? Well, your calculator gives you way too many significant figures. And when you're doing various operations like multiplication, division, addition, and subtraction, you should know how to do this. And for multiplication, division, the number of significant figures in the answer is the same as the number of significant figures that the measurement, the number that contains in the measurement that contains the fewest significant figures. When you do a multiplication and division, the answer has the same number of significant figures as the number you're multiplying or dividing that has the fewest significant figures. Now, here's the rule for addition, subtraction. We're not going to be using that for a long time, so I'm not asking you to learn that for quiz 1, which is why I gave you a big hint. See, big hint. Know how to do this. That's just for multiplication division for quiz 1. And also quiz 2, 3, 4, 5, and test 1 and 2. All right. If I were to ask you under your name in quiz 1, 2, 3, 4, 5, 6, test 1 and 2, it will say, please use proper significant figures for all calculated answers. And if you don't or you get it wrong, I will take off 1 point for a problem like that. So what would be the answer for this? Well, 4 divided by 2 is 2, but that's only one significant figure. If we look at 4.00, 4 is significant and zeros after the decimal are. So this is 3 significant figures. And 2.0, the 2 is significant, a decimal point, so the 0 is 2 significant figures. So the question is, which one of those is lower, 2 or 3? Time's up. Hopefully I'll pick 2. Therefore, to make this 2 significant figures, I put a 0 there. Now, when you use a calculator, it gives you a lot of numbers. And let me show you an example. And quiz 1, if I were to ask you to give the answer to that, what would you do? You use your calculator, and I'll show you in a second how to use the calculator, but I'm going to do it real quick. 4.173 times 10 to the 6 divided by 2.13 times 10 to squared. And my calculator gives me this number. It actually says 0.4, but I dropped the 0 after 10. You don't need to put that in there. Well, if you wrote that down, this were 2 points, I'd take off a point because you didn't use significant figures to determine the answer. How do we do that? This is a division. You get the same number of significant figures in your answer as the number you're multiplying and dividing that has the fewest significant figures. This one, all non-zero numbers are significant. 1, 2, 3, 4. The bottom one, 2.13, all non-zero numbers are significant. 1, 2, 3. Which is smaller, 3 or 4? Time's up. Hopefully I'll pick 3. So now we have to round this number off to 3 significant figures. And how do we do that? Keep the 1, keep the 9, keep the 5. This is a 9. This is the number we use to round off. Is that 4 or less or 5 or higher? And it's 5 or higher. So I drop this and everything afterward and increase this by 1. So the correct answer for this number using significant figures would be this. And that's the skill that I teach in the videos, and they're practice problems for that. Let's talk about a calculator. I'm in my syllabus, I recommend you buy this one. It's about anywhere from $10 to $15 where you buy it. This one, I don't know how many years old it is, but it's still going, and it's solar powered, so I haven't had to change the battery. But anyways, let's look at how to do scientific notation on here. First of all, you have to make sure you're in scientific notation. And this is the second key, where this one here is yellow color. Other calculators, they're slightly different color. If I push this and then this second key, notice SCI is underlined. You can use this to change to a different one, but I'm going to keep it that and hit enter. And if you look right down here, it says SCI, and that tells you it's in scientific notation. Now, how do you do scientific notation on here? Good question. Thank you. And on a test, if you had to do this calculation, 2.11 times 10 squared times 3.33 times 10 cubed, how do you do that? Well, let me show you. First of all, make sure you clear. Oh no, I forgot to do my nails. Don't look. Don't ever do my, all right, now I have 2.11. I use the keyboard here. Now, to get 10 to the squared, second key, and see down here above it says double E. I'll push that. And now up here, there's a letter E. And that's like 10 to the power. And I want 2. So I'll now put 2. Now I want to multiply it. So I'll use this button here, and you'll see a star. Now I believe I had 3.33. So I put that in. Now to get the exponent, 10 to the third, second key, double E right here, and now I'll put 3. And now I will hit enter, and here's the number I get, 7.0563. And see right here on mine, it's real tiny. Get your magnifying glass. It says 10 x10, and then the number right after that, 0.5, so that would be times 10 to the fifth. Now, let's go back to this problem. So my calculator gives me this number. But as it says on quiz 1 and all the other quizzes and tests, please use proper significant figures for all calculated answers. This is 3 significant figures. All non-zero numbers are significant. This has also 3 significant figures. When you do multiplication and division, the number you get is the same as the number your multiplier divide that has the fewest significant figures. In this case, this is both 3. So we now have to round this off to 3 significant figures. So the first number I keep, 0 after decimal is always, or when a decimal is present, is always significant, 2. So those are my 3. The next number I'll use to round off. And 6, is that 4 or less or 5 or higher? And hopefully I'll pick 5 or higher. So I'll drop that into 3, increase this by 1. And this part doesn't change. And there you go. Now, let's look at something important. And that's when the exponent is negative. So here I have 1.11 times 10 to the minus 6 times 2.222 times 10 to the minus 4. And I clear my calculator. I'm going to put 1.11, second key, double E right here. Now, how do you do a negative number? You do not use the minus. This is not for negative. You use the 1 on the keypad. When you want a negative number for your exponent, and watch what happens. I'm going to push it. See it put a minus there? And I want 6. So that's 1.11 times 10 to the minus 6. When you want to do a negative 10 to the power, yellow key, second key, double E. See the double E above the button itself? And then use this, not this. Dr. White will never be a hand model on TV. Nah. They make a lot of money, but not my calling in life. All right, now I want to multiply that times 2.222 times 10 to the minus 4. So I put my 2.2 to multiply. That's how I got the star. Then I put in 2.222. Now I want 10 to the minus, I believe I had 4. So anytime you're doing the exponent, second key, double E, that's the number above this button. And now to get a negative, use this, not this is for minus, subtraction. This is for the exponent, and see, and now push 4, and I'll hit equal. And let's go and look. And my calculator gives me this number. And if you look closely on here, it's minus 10. Now, remember, when you multiply and divide, you get the same number of significant figures in your answer as the number with the fewest. All non-zero numbers are significant. 1, 2, 3. 3 significant figures. 1, 2, 3, 4. 4 significant figures. Let's try that F again. That's better. So how many significant figures should your answer be? You get the same number of significant figures in your answer as the number with the fewest significant figures. So this is 3, 4, which is smaller, and times up, hopefully you pick 3. So you now have to round this off to 3 significant figures. Keep the 2, keep the 4, keep the 6. That's my 3 significant figures. Use this to round off. Is that 4 or less or 5 or higher? It's 5 or higher. So I'll drop this and these numbers. This you don't change. And this one, since it was 5 or higher, the 6 is increased by 1. And the correct answer here is 2.47 times 10 to the minus 10. And that's how you use your calculator. And with that, I'm done with the review. Remember, do the practice problems. Thursday morning, I'll send out the password. Now, Thursday morning, I have some things I have to do, so I won't be able to check my email until about 3 p.m. on Thursday if you have any questions. If you have any questions, send an email. And from 3 until 9 p.m. on Thursday. And Thursday morning, I have an appointment, but after 10:30, I'll check my email every 2 hours. Be sure to get it uploaded as a single PDF file, and that's that. You'll do well if you've done the practice problems and watched the video. Good evening, everybody, again. This is Chem 1211, and guess what? Wait, I forgot to talk about 2 important areas for quiz 1. So I'm adding this at the end of this video. All right, the first thing is how many electrons and protons are in an element. And how do you do that? You look at the periodic table. And if we look at hydrogen, H, the number in the upper right-hand corner, 1, tells us, that's called the atomic number, there's 1 electron and 1 proton. The atomic number equals the number of electrons and protons. So the atomic number equals the number of protons in an element and also equals the number of electrons. And I'll teach you later that's because all elements have a net zero charge. But you should know the atomic number equals the number of protons, which also equals the number of electrons. And you should know how to determine from the periodic table how many electrons and protons carbon has. Well, excuse me. Chemical symbol is C. Here it is. atomic number is 6, so there's 6 electrons, 6 protons. If I ask you, how many electrons and protons does krypton have? Krypton Kr, atomic number is 36. That's the number in the upper right-hand corner. And that tells you there are 36 protons and 36 electrons. Ooh, let's go to the high rent district. How many electrons and protons in gold? Ooh, what's the chemical symbol for gold? Au. And its atomic number is 79. So you know there's 79 protons and 79 electrons. Again, the atomic number, the number in the upper right-hand corner of the periodic table, tells you how many protons and how many electrons. Now, the other thing I forgot to talk about in the live review was so if I were to ask you how many atoms are in each of the following molecules, I should have had this, each of the following molecules. Let's look at something. This is NaCl, sodium chloride, and that's table salt. And there's 1 sodium and 1 chlorine. And that tells you there are 2 atoms. Now, another molecule is H2O, water. And when you have an element and to the right and subscript low, that number tells me there are 2 hydrogens, and here 1 oxygen. Add that up, there are 3 atoms in water. Now, there's a thing called parentheses, and we'll talk about polyatomic ions. And let's look at magnesium hydroxide, Mg, bracket OH, close bracket 2. Now, when you see these brackets, that tells you everything inside is multiplied by the number to the right subscript of that molecule or that atom in there. So in this molecule, how many atoms? There's 1 magnesium, but 1 times 2 is 2 oxygen, 1 hydrogen times 2, 2 hydrogen. There are 5 atoms. And that's how you use those brackets. So again, you count the elements in the first one, 1 sodium, 1 chlorine. In the second one, when there's a number to the right subscript of an element, that tells you how many of that element. 2 hydrogen, when there's no number, it's 1. 1 oxygen, 3 atoms. When there's a bracket, everything inside is multiplied by the number to the right and underneath that bracket. In this case, It's number 2. So there's 1 magnesium, but 2 times 1, 2 hydrogen, oxygen, and 2 hydrogen. That's why there's 5 atoms. And you should know how to do this. And with that, I'm done with the part I forgot to do. Boy, bad Dr. White. And with that, I'll say gang gesund. Bye now for the second time. Stole that from Granny to Beverly Hillbillies. Bye.